Section 9.3 demonstrates one of the hardest parts about this last third of the class, which is when you're given a bunch of different problems and they're not specifically telling you exactly where to go. There's two different parameters that we're looking at so far, the proportion and the mean. And then we can either, for each of these, find a sample size that we would need in order to get the confidence interval, or we could find the confidence interval itself. And making that decision can be a little tricky, so we're going to go through a few problems. This first one is especially tricky because of what it has you do. So it says a teacher wants to study the average amount of time spent by students studying for their class. This teacher wants to collect enough data to be within 15 minutes of the actual amount of time spent. A preliminary study of 10 students is given in the table below. And we can see those amounts of times per week spent studying there. And if we assume the standard deviation is similar for a larger sample and that the amount of time studying follows a normal distribution, how many more students should this teacher include in the study to be 99% sure that the average is within 15 minutes of the actual average time spent? Now, the first thing is I usually decide, what are we doing? Are we making a confidence interval or are we finding a sample size? It should be fairly straightforward, where whenever you hear like how many or what sample size should be used, that tells us that we're finding the sample size. So we know the file that we're going to need to use, which in this case is the find sample size. And then from there, we have to decide between the two sheets. This one only has two sheets. We have the mean or we have the proportion. And for this one, I look at this word average here. We also have a standard deviation. So that's for the mean. So we need to use the mean sheet. Okay, I'm going to let it guide me to open up that file, this one here, and I'm on the proportion sheet, so I have to switch to the mean sheet, the first one. And there's three different things that I need to find, which I'm going to write down. The margin of error, the confidence level, and the standard deviation. Those three things. So let me go back here. To find those three things from the wording. Now, the first thing, margin of error, I look for this word within, and that tells me the margin of error. So within 15 minutes. That's what I need. Confidence level, that's pretty easy as well. That's this 99% right here. So I'll put 0.99. And then the last thing is the standard deviation, which this one is not straightforward. It has a word here. We have the word standard deviation. And it's telling us that it will be similar for a larger sample. So we need to take this data here and find the standard deviation. Even more specifically, since this is in, the margin of error is in minutes, we need to find that standard deviation in minutes. So I copied the data into Excel already, so I want to show you how to do this. It's a couple different ways. Here's the data file. I have the hours and the minutes. We want this to all be in minutes. So I'm going to just write here total time in minutes. me make this a little bit bigger. I'm going to use a formula to do this. So an hour has 60 minutes, so we want to multiply each of the hours by 60 minutes and then add the number of minutes here. And I can use a formula to do this. So I'll do equals 60 times the number of hours there plus the minutes here. And one cool thing we can do is we can use the fill handle. It'll take those references and do that for each of our rows that we have. So it saves a little bit of time. Let me just show you one of them. See, it'll do the same calculation, but in a different row. Uses the same columns that are there, which is really nice. It does those calculations very quickly. Now that we have the total minutes in our movies, we can find the standard deviation. A couple different ways to do this. We could open up the descriptive statistics. That was the Excel file that we used for standard deviation. Or you can just calculate it using the built-in function using Excel. I'm just going to use that because I know what it is. stdev dot, and we want to use S for this one. I'm going to use the sample the sample standard deviation here. So I highlight all those, close that off. You can also just type the full thing there and it will give you the standard deviation. And it gives me, when I press enter, 49.8196748. This number here. Now, this is the standard deviation that we're going to use. I'll write that down, but ultimately I'm going to copy it into the find the sample size one. So let me just write that down, 8196748 is a pretty large standard deviation too. So I'll copy, and going back to the mean one, this was the standard deviation. I'm going to paste that value in there. And the other things I fill in, 15 minutes for this one and 99%, keep that the same. And it calculates for us right away. It gives us 74. This one down here, the sample size that we would need. So let me show you what I was writing down. Okay, and let me just make arrows here. I'll say done in Excel. Yeah, so 74. One thing to make sure you pay close attention to, and it's just one word, so it's kind of sneaky how many more it's asking for. So the answer really isn't 74. We have to take away what we already have. And we already have 10 different, a small sample of 10 already, 10 different numbers of times. So we subtract away 10, and it gives us 64 more students. $64 more. Okay, that one is especially tricky. So let's do one. It's a little bit more straightforward. It says a researcher is studying the weights of male Cecropia moths, and they know that the weights follow a normal distribution. They collect data on 34 Cecropia moths and find the sample mean to be 44.6. Sample standard deviation is 5.4. And it says construct a 98% confidence interval for the mean weights of male Cecropia moths. Okay, so this is constructing a confidence interval. So there's 3 different steps that we need to do for this. First one is though that we need to check the conditions. Okay, so the first one we remember, hopefully, is that random sampling was used. Now, it doesn't explicitly say it, but let's just assume random sampling was used. If you weren't the researcher and they're just giving you their information, like those means and the standard deviations, you may want to just ask them really quickly, did you use random sampling? And if then they have further questions, just explain what random sampling is and why it's so important that we have random sampling. Now, the second condition is the normal criteria. And for this one, they're saying that the original distribution follows a normal distribution. That's great. That means there's no issues with looking at the sampling distribution. So we can say for this condition, the original distribution is normal, and therefore the sampling distribution is also normal, which is good. Also, the sample size was pretty big, 34, so it would meet the conditions even if the original was not normal. Okay, now the last one, they're not really giving us much information about the population, but there are millions of Cecropia moths, so 34 is definitely less than 5% of millions. If you get a chance, they're very cool looking, very fluffy. They're kind of cute. If you ever want to look up some photos to make you smile. Okay, now it meets all of the conditions, and I guess I should right here, we have independent sampling. Just good. So we are good with checking our conditions. Just going to make a box around this. Okay, now our next step is to compute. We're going to use the confidence interval. And we're using the mean sheet, since this is looking at a mean. And we also want to use, I'm going to note here, use the left side, since they're not giving us data, but they're rather giving us statistics. Okay, so I'm going to go there, and this is not the right one, so I got to change to this one. I'm on the mean sheet already, which is good. I'm using this left side since I'm not given the data. I'm not given those 34 numbers, just given the results of getting the mean and the standard deviation. I need to identify X bar. So I'm just going to write this down. X bar, the standard deviation S, the confidence level C, and the sample size N. those four things. Come back to here. And we'll identify sample mean, that's X bar, that's what that symbol stands for, 44.6. Standard deviation 5.4. Confidence level is 98%. And the sample size is 34. So double check that you can identify in the wording all of those things. Super important. Once I have those in though, it'll give me a lower limit and an upper limit. So let me put that in over here. Oops. Keep this up. There we go. 34. Okay. Double check I plugged everything in correctly. Looks good. Again, my lower limit 42.33. I'll round it 336 and 46.864. Both of these are in grams. Okay, now our last step, we need to interpret the results. So let's write down here. I'm going to put, we are 98% confident that the mean weight of Cecropia moths, or male Cecropia moths, is somewhere between 42.336 grams and 46.864 grams. Okay, cool. Yeah, these are pretty cool critters. I used to have a bunch of them, raise them from caterpillars. They have an interesting life cycle too. Live most of their life as, I guess, cocoons, and then caterpillars is second, but their life in the moth form is just for usually a few days, maybe up to a week. They mate and then lay eggs and they die. They don't eat anything in their adult form. Okay, so let's move on to example 3. It says you are measuring the temperatures of Christmas lights produced at a factory that produces millions of lights. You measure 550 randomly selected light bulbs and find that the sample mean was 815, the standard deviation 20.1, and suppose that the temperature of the light bulbs is mound-shaped and symmetric. Construct a 95% confidence interval for the population mean temperature of those Christmas lights produced at this factory. Okay, So same thing. This is actually the same situation as example 2. There's one small difference. The original distribution is not normal. And so we have, when we check our conditions, they're going to be just a tiny little bit different. So let me just write here, check conditions. And the first one, random sampling, it says randomly selected. That's good. So random sampling was used. We don't have to assume random sampling in this point. Number 2, now we do have to check that the sample size is large enough. The sample size is 550, which is greater than 30. And because of this, we can say the sampling distribution is approximately normal. So this normal versus approximately normal, that's a kind of small difference between the two, but it is something that you should know. When you have to check that condition, it's not automatically normal, it's approximately normal. Then the last one, they make millions of Christmas lights. So 550 is definitely less than millions. So let me just write that. 550 is less than or equal to 5% of millions. And so we have independent sampling. Okay, those conditions are met, which is good. So we can move on to our computation. And I'm actually just going to copy what I have here because it's the same exact situation. Well, different situation, but the same sheet that we're using. We're looking at the mean, confidence interval for the mean. And we need X bar, just noting what I have up there. S, standard deviation, C, and N. So we need to identify those 4 things. Sample mean is the first one, 815. Sample standard deviation is the second, 20.1. Confidence level, 0.95. Sample size was 550. We'll plug those in, and that will give us our lower limit and our upper limit. So let's do that over here. Okay. So our lower limit, 813 point, I'm just going to round to 3, 816.7. This is in Kelvin. A kind of strange way of measuring temperature. It's closely related to degrees Celsius. I forget the number that you add, but it's just addition. Okay, cool. Now we can interpret this. So very similar to what we did before. We can say we are 95% confident that the mean temperature of all lights at this factory is somewhere between 813.3 Kelvin and 816.7 Kelvin. Okay, so here's another example. It says you're taking an analytical chemistry class and need to determine the concentration of a sample of hydrochloric acid. Your professor tells you that your sample is either 10%, 15%, 20%, 25%, or 30% hydrochloric acid. You measure the concentration by titrating with sodium hydroxide 10 times and you get the following results. It says assume the conditions for constructing a confidence interval are satisfied, and we're going to construct a 95% confidence interval. And then they're asking us an additional question: are you confident that you can identify the correct concentration? Okay, so ignore the conditions. Let me just put here, don't check conditions. In some cases, we can do that. Okay, so the next step, we need to construct a confidence interval. So we'll use the confidence interval Excel file. And they're giving us data, so it should be a kind of a clear indication. You want to use the mean. And for this one, where is the word? Confidence interval. Yeah, so it's not, they don't really, it doesn't say the word average or mean, but we would want to find the mean concentration percentage that we have here. Concentration for acids are usually not done in percentages, are usually done in molarity, but we can add these all together and then find the mean by dividing by 10. That's what we would want to do. So we're going to use the mean sheet. And since we're given the data, use right side, which is the data side. Okay, the only thing that we plug in with the data is the confidence level, which is 0.95. And so I want to show you how to do this. I have the data typed out already just to save a little bit of time. So I'm taking those percentages. I'm just going to leave them in this form and copy and paste into the right side of the mean sheet. Get rid of those extra ones. And 95%, this one here, that's good. It calculates for us our lower and our upper limit, which I'm going to write down. So lower limit, I'll just do, I guess I'll do 3 decimal places, 18.999%. And our upper limit is 21.401%. Okay, now we have to answer the question. And it says, are you confident that you can identify the correct concentration? Well, we look at the range of where we think it is. And there's only one of these concentrations here that fall within that range. So we could say we're fairly confident that our concentration was 20%, the one that our professor gave us. Now this actually comes from some experience that I've had. I was a chemistry undergrad major, and for the lab in this class, if we didn't get the correct concentration, we actually ended up failing the lab. So whenever you constructed your confidence interval, you're excited if it just contained one of the concentrations, and disappointed when it contained more than one, because you were kind of guessing which one it would be. Yeah, it was a big reason why I chose not to go into chemistry. That class was pretty intense, and I didn't like the lab work very much. But anyway, I'm in a good career. I love my job. We'll do the rest in another video.